everybody. Welcome to our class on Calculus for Life Sciences. We're still very much busy with our review, and we have the last little bit to do on quadratic functions. Let me just get set up here. All right, should be good to go. Now, let's think, where did we end last time? We started an example for completing the square, right? Okay, so we have the standard form, or our PQ form as I like to call it, of my quadratic function versus the general form, which is y equals ax squared plus bx plus c. Now, I guess pros and cons to both. But for our immediate pre-calculus purposes, it's certainly the standard form that gives us the most direct information, that I can see the transformations. And mute. I can see the transformations more clearly, make my chain of transformations, graph them, see what happens in everything. I can see the vertex right there, P and Q. I can see what happens by way of A. Everything is nice and clear. Whereas the general form is what I mostly have from a question, to be honest. And it's not as clear what the graph looks like and everything, what the transformations are and things like that. I see the A is still there. That's nice. But apart from that, it's a little bit more hidden. So I want to, from the, where's my line there? If I have the standard form, going to the general form is easy because I just simplify. But to go back from the general form to my preferred standard form, I have to complete the square. So I want to do a problem. Which problem do I want to do? I wrote this down. 1.6 number 3. No, we did 1.6 number 3. I want to do 1.6 number 6. Yes, that's a nice one. So we'll do problem 1.6 number 6, where we have, whether you call it y or f of x, it really doesn't matter, negative 3x squared plus 4x minus 7. Now, I'm more interested in completing the square. I'm not as worried about the graphing. We've done an example where if we have the standard form, we can make our sequence of transformations, graph them carefully, systematically, and it's just a matter of time. It's completing the square that I'm trying to practice at this stage. So I might not do these questions completely, and that's okay. So let's see. Now we have as general as we can get it. Let's see what we have here. Now, the first thing I have to do is I want to take out this A because it's going to complicate things significantly. Last time in our number 3 problem that we did, we only had an x squared, so it wasn't an issue. If you have a number other than 1 in front of the x squared, then you have to remove that as a factor first, so that you can look at a clean x squared before moving on, regardless of what it might cause the other terms to be. So now I'm going to have a minus 4 over 3x, and I'm actually some people like to do the same for the 7. I actually want to just leave the 7 at the end. I don't care for it. It's not a part of the numbers that I want. There's no need to take 3 out of that one. Later, I'm just going to have to put it back. But I do want it out of the x terms. So that when I multiply the negative 3 in, I get my first term. Negative 3 in there, the 3's cancel. I get plus 4x, and the 7 is left. It doesn't want to play with us. Okay. Now, let me come up with a plan here. I know that I'm going to need 3 terms to become a bracket squared. The 7 is still there. I can't just add this question mark. Regardless of where I'm adding it, I can't just put it in because I want to. I have to balance it by whatever that number is, taking it away as well. I don't know what that number is yet, but I know that these 3 terms with the correct question mark will become x minus some number p squared. I still have this guy. They're still in large brackets. The negative 7 is still there. The negative 3 is still in front as well. Okay, so this is the key part here where people get confused. I'm just sort of planning it out. I need a question mark number to be the third part to create my bracket squared. Because that was a minus, I know this is going to be a minus. And because I'm squaring this p in the end, that's going to be a plus question mark. Which means the minus question mark is always extra. I need it there for balancing purposes, but that's about it. So now, if I go on the side here, maybe, I say, well, x minus p squared is going to be x squared minus 2px plus p squared. I'm trying to hit this minus 2px to get a target of minus 4 over 3x because I'm stuck with the minus 4 over 3. So that means that minus 2p has to be minus 4 over 3 because that's the coefficient of the x that I see. Now the negatives don't really matter because they are already, I made sure they are correct. So that means, I'm running out of space here. This line was a little bit too high. I need one more line like that. That means that p is 2/3 because I divide by 2 on both sides, creating 2/3. So that means this guy needs to update. 2 2/3, which then makes the question mark value, erase, 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 2/3 squared. And that makes the other question mark, erase, 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 the same, 2/3 squared, which makes this question mark, of course, the same. Well, I can simplify it at this stage to 4 over 9. So there's sort of a back and forth, up and down thing happening here as I fill in the unknown symbols that I had temporarily. Okay. Now, I will say at this stage, if you remember completing the square that you've done in a previous course, you remember it well, you got used to it, it made sense, and it's not quite the same as what I've done here, go back to that. There are slight variations resulting in the exact same thing, and it really depends on what works for you. This works for me. Trying to think about it more, mapping it out. What are the pieces that I need? Where do the pieces go? And then systematically filling in the pieces. This is technically, it is technically review. And if you find that what we're doing here is extremely confusing and unfamiliar, it is up to you to go and find a pre-calculus book, open book, go to Khan Academy, go wherever you need to go. Maybe you have your old textbook and review more if you need to. This is just, our first couple of weeks are just to highlight things you need to know, but I can't repeat a full pre-calculus course, of course. Question in YouTube. Quadratic functions, general form, what is bx? I'm guessing, what is bx in the general form? The whole problem is, in that general form, yes, the a is still there, so we know what the a means. We don't really know directly what the b and the c mean. It's not as nice and convenient as the p and the q giving me my vertex directly. The general form has things more hidden. In order to see where the -3, 4, and 7 come into play to create or to reference the vertex, completing the square is what we have to do when we have a specific example. So we're still in the process of doing that, but the hard part's over. I want to now multiply the -3 back in, so -3 times my bracket squared. Then -3 times -4/9, unpleasant as it is, what are you going to do? Plus 12/9, and of course I still have the 7. All we have to do is now merge these last two to create the constant, well, it's not the constant term, the q in the standard form. Now, you can use your calculator. I want to keep it as a fraction instead of a decimal. I don't want to round it. You can do it by hand to say, well, 12/9 minus 7 is, put both over 9. Oops, that's not an equal sign. It is a minus. Minus, how much is 7? 7 is what over 9? So over 9, 12 minus 63. I'll show you here that MathBot can do basic calculations in the Discord chat as well. This is a good time to demonstrate it. I don't know if it can keep fractions. I think it'll just make them decimals, but let's demonstrate MathBot. 2 equal signs, 12 minus 63. Just as a demonstration. We'll use MathBot more and more as we go, but there isn't a lot of opportunity right now. So of course I get my -51. So it's unpleasant. Doesn't look right, but you can certainly double check this afterwards as well. The completing the square method is this way. I like to do it this way. I'm more of a planning and filling in method to really see if I understand what is happening here. I don't know what the answer is. It could be 51/9. It looks okay. And so I have my P here, I have my Q here, I have my A here, and I can make the sequence of transformations. I can definitely find the vertex. It's just PQ. Remember, P is just without the minus. Q is technically with the minus if there is one. So the vertex is 2/3 and -51/9. And obviously, with these unpleasant fractions, we don't want to bother graphing something like this. It'll be too time consuming. And I can see my A is -3, which is negative, which means in the sequence of transformations, I am going to flip my parabola and create a maximum point and all those things. All those things are fairly easy if I have the standard form, regardless of the unpleasant fractions. That usually happens when I just have some integers here in my general form. Often the vertex location is a little unpleasant. All right. So you decide how you feel about completing the square. It is unfortunately necessary if I want to go from the general form to see the standard form and the vertex and everything. But luckily, one could, if you take the general form without a specific example, y equals ax squared plus bx plus c, and you leave them general a, b, c, then you complete the square on that. So if you take that in general and complete the square without specific numbers, it's messy because everything's in symbols. It takes a long time. You just have to slowly be keeping track of everything. Then we get that the p is negative b over 2a. So in my standard form, and I'm not doing the whole thing for reasons I'll say in a second, you get this. I don't really bother memorizing the other part for reasons I'll say soon. So if you just not take a specific general form, you leave it as general as you can with A, B, and C, do the completing the square, slowly make progress, you're going to get something like this, which tells me exactly the x-coordinate of the vertex. So that then means that the vertex is negative b over 2a for the x-coordinate. Now there is a y-coordinate. I don't write it on purpose because I don't want people to memorize something that is completely unnecessary. This then also means the axis of symmetry. Remember, that is the x-coordinate of the vertex is then going to be the line x equals negative b over 2a. Now, how do I find the y-coordinate? If this is my f of x function, then I simply plug in the x-coordinate into the function to find the y-coordinate. There's no issues at all. Let me visualize that. If I have my parabola maybe over here, ooh, that's a nice parabola, man, good. My axis of symmetry is right in line with the vertex, negative b over 2a. If I want to find the corresponding of the y-coordinate for that point, I'm not going to memorize b squared minus 4ac and whatever else. I don't even care. At this stage, I don't care. I plug it into my function and get the y-coordinate. Because what if I memorize this wrong? It's longer, it's messier. I don't even want to look at it, honestly. I realized very quickly, like, I don't need to memorize this. If I understand functions, I only need an x value. I can always find the y value. I don't need to memorize two different formulas. They're linked anyway. Don't care. So it is all there, and I can sidestep this then. But if I have the general form, I can sidestep completing the square because I can do it once in general, and I'm not going to bore you with half an hour of that. I did it once. I do it in pre-calculus. I do it in general, and it takes about a whole class, and you can see people falling asleep. They're just not interested, where I find it quite interesting or challenging to keep track of everything. It's not the best thing. The most entertaining thing to do, rather. So if I trust that it's done correctly, I could just memorize negative b over 2a. And that sidesteps the whole completing the square. I can't see the transformations, but at least I know where the vertex sits, which is the key part of the quadratic function anyway. So it depends on your goals. If you want to see the transformations, now you're going to have to go to the standard form. If you just want to have a rough graph of the parabola, you just really need the vertex, right? And if I have the x-coordinate, then the y-coordinate and everything is pretty straightforward. So let us do a problem like that, where I don't go to the standard form. I take the general form as it is and just get the graph end result from that. This might look a little bit more familiar, perhaps. Which one do I want to do? I don't know. Let's take 1.6 number. Number 8's fine. Let's do number 8. Where I have f of x equal, I don't have the problem book open, but I'll just write it down for you. You don't need to look in the problem book. It is just giving me exactly this. Plus 5x plus 4, random general form quadratic function. Okay. I don't want to write it to standard form. I don't want to do the sequence of transformations. I just want to jump to the end. So there are a couple of things here that I like to do. First of all, I want to note the a, which is -3, which whether I do the transformations directly or not, it means, because it is negative, it means that my parabola is flipped around and I do eventually have the maximum at the vertex when I find it eventually. Okay. It's stretched a little bit, but who cares? Then I want to find the axis of symmetry, which is the line x equals -b/2a, which is -5/2 times -3, which is 5/6. Now, if I did completing the square, this 5/6 would come out after a little bit of work. I get it right away by just remembering -b/2a. So it's my shortcut. Now, let me see. Maybe the maximum. I know there's going to be a maximum, right? Because the value of a tells me that it's going to be a maximum. I want to find the maximum value, maximum function value, which is the y-coordinate of the vertex, is f of 5/6. And I can calculate that with the calculator. Let's see if MathBot can do that. That's my calculator. I don't have an actual calculator in front of me. I trust MathBot as my calculator. So I just have to slowly put 5/6 in everywhere, and let's see what we get. So I have -3, oops, no, 2 equal signs, MathBot. -3 times, I have to square 5/6. Then add 5 times 5/6. Then add 4. What does MathBot say? MathBot says, oh, it gives me a fraction as well. That is very nice. 73/12. Or I don't really want to round it. I'll leave it as a fraction. So that means my vertex is 5/6, 73/12, the point. Let's do a little graph here. I have enough information to have a rough idea of the graph. X and y. Now these are unpleasant fractions, right? They're all positive. The x-coordinate is a little small. Let's put it fairly close at 5/6. Y-coordinate is much higher. Let's put it over there at 73/12, and I know it's bending down. Now, what would be nice to know is it really narrow and going down like this? Or is it a little flatter and going down like that? if I know the y coordinate, then I have a better idea of how I should curve it. So let's find the y, not the y coordinate, y-intercept, I mean. The y-intercept, of course, that is just where I set x equal to 0. So that will be y equal to f of 0. And if I look at my function, if I have 0 for x, the first term falls away, the second term falls away, and that's always going to be the case. So the constant term that I get in my general form is actually the y-intercept. And that's always going to be the case. So there's more in the general form than I might have thought. That c is the y-intercept. So it's not so bad. So I don't even have to calculate anything. It's 4. So now I know I don't have a parabola too narrow. I'm going to cross maybe somewhere over here. And I don't care about the scale or anything. I'm just going to mark it off, and that's 4. Now I just want to make sure my parabola is round at the vertex. I don't want it to be sharp or pointy or anything. And I also don't want it to bend the other way. Those are the two things I want to be aware of. Don't feel restricted. Don't do it on graph paper or something like that. Then you're going to really get wobbly trying to hit the point that's sort of preset for you. Just follow a nice curvature and let the scale be whatever it is. I remember in high school, we had to open our books for the teacher to see that we did our homework, and he would walk by and check that you did your homework and so on. I think we were drawing circles or ellipses or something. That doesn't matter. And I focused on the shape of it, nice and round. And I adjusted the scale of my two axes so that it would make a nice shape. And when he saw that, he freaked out. Like, no, you can't change the scale on X and Y. It has to be the same. Like, why? Why does it have to be the same? Why don't I just rather look at a pretty picture? It's the same. It doesn't change anything. I don't know. I still don't understand. But whatever. He had his right to freak out if he wanted to. So let me zoom out here. Knowing some shortcuts or formulas, if you will, I can take the general form and figure out enough of the quadratic function, the parabola, to be satisfied. Now, that doesn't necessarily work in the same way for other functions, whereas the transformations are always the same. So there's pros and cons. If I have a quadratic function, the negative b over 2a works for that function. It's now specific to this kind of function, whereas the transformations were done in general, that if I replace x with x minus 2, regardless of the function, the previous graph shifts to the left, or did I say minus 2? Shifts to the right by 2. The transformations are sort of universal, not dependent on the function. If I sidestep them with formulas and shortcuts, well, then it's function specific. Let's make a nice round parabola here. So I have a couple of things that I want to do. I have my A indicating the maximum or minimum, whether it was flipped. I don't have to actually do it. Axis of symmetry, I do have to remember that guy, which is not, it's a big formula. So some of these things are familiar, or as soon as I mention it, like, oh yeah, right, negative b over 2a. Not hard to remember. And I make a point of not remembering the y coordinate of the vertex, right? Why would I memorize something I never need, right? I can just plug it in. Many people spend a lot of time memorizing the other one. I don't care. And I have my vertex from that. Y-intercept, certainly important. And then there's one thing missing, and that is, of course, maybe they want, or you want, the X-intercepts. So that's the very last thing you may want to do, okay? Let's just see where we're at here, if I have space at the bottom. Yeah, I have it. I have some space. Okay. So I have y equals ax squared plus bx plus c. Now we showed, maybe, let me do it this way. Let me do an example. A simple one. I'm just going to make a standard form one. Let's say 2x minus 1 squared plus 3. Oh, no, not plus 3, minus 3. Like that. We did do this once, that if I wanted to find the X-intercept is what I'm looking for. It's the last thing, right? Then here I set y equal to 0. I have to solve 0. I'm going to flip it around. Plugging in 0 for y, I have to solve that. Now, if I have it in standard form, that's not that big a deal. I move the 3 to the other side. I divide by 2. So it's 3 over 2. I then get rid of the square by square rooting everything, remembering that it's a plus or a minus. And then I add 1 on both sides. Because that doesn't have a plus minus, I'll put it at the front. Plus minus root 3 over 2. Calculate that. I have 2 of them, right? One with a plus and one with a minus. That's not that big a deal. We've done one like that, and that shouldn't be a problem for anyone. I'm not saying it's the same function here. I'm just making a random example. If I now have an ax squared plus bx plus c general form, then my x-intercept, and this is probably the thing people remember the most, is still to solve the equation I get when I plug in 0 for y. Now, if you go through the whole song and dance, completing the square from this general form, getting it into standard form, then doing this same thing, you're going to get what we call the quadratic formula. Negative b plus or minus square root of b squared minus 4ac over 2a. But it's important to, whether you see it or not, and I'm happy to do it, it just takes like half an hour or more, because you have to be so careful. Nothing simplifies with the a, b, and the c general. When you do write it to standard form by completing the square, do what we did on the left here, you will get the quadratic formula. It's not made up. It comes from keeping everything general and just going super slow. So if we want to, in general, find the x-intercepts, the quadratic formula is always there as a worst case scenario. So let's do it on this function. Ooh, we have some space, not a lot. Let's hope it's enough. X-intercept. Looking at the graph, I know there will be 2, but sometimes there is, sometimes there isn't. So it's going to be x. I'm going to write it down again. Negative b plus or minus square root of 4. No. B squared minus 4ac over 2a. Okay, now let's plug it in for this specific situation. I have to scroll up to remember what is b. It is a 5. So negative 5 plus or minus square root of 5 squared minus 4 times, what was a? Negative 3. Negative 3. What was c? C was 4. C was 4, right? C was 4. So times 4 all over 2 times a was negative 3, right? So I have that. Now, how you go about calculating this is to some degree up to you. Some people like to do it all in one. Some people like to calculate just the square root first, and all kinds of things in between. I kind of like to just break it up into a couple of pieces. Let's find what's inside the square root first. So I don't have to do 5 squared, I know it's 25. Oopsie, not plus. Oh, it's going to be a plus, yeah. 2 negatives. 4 times 3 times 4. So just inside the square root, of course, it's not a nice square. It's a 73. But at least now it's going to look much less intimidating. And then I have the bottom here, negative 6. So now this shows how it splits into two. One is negative 5 plus root 73 over negative 6. And the other one is negative 5 minus root 73 over negative 6. Let's see what we get here. And I'm going slowly on purpose so that maybe you want to take out your calculator or an app on your phone or something to see if you can do it yourself rather than waiting for me to do it. I'll slowly see if MathBot can do it, but I encourage you to, in that time, see if you can do it yourself. And then see, maybe I'm doing it wrong. Double check. You have to double check if I do it right, or if MathBot does it right. Let's see. So I just have to remember the square root function in MathBot. Let's just see how that works. Let's test it on 9 or something. I think it's just square root, like so. Yep, okay, MathBot likes that. That's the function. So let me see the first one then. So it's going to be now brackets, right? Negative 5 plus square root of 73 bracket divided by bracket negative 6 bracket. Let's see what MathBot does there. For the top one as negative 0.590667 blah blah blah, which we can round to negative 0.59. I'll say 0.7. I like at least 4 decimals. 2 decimals make me nervous, though. If it wasn't specified, you certainly can, and that 0 definitely encourages that. But if it's in a future calculation, I can easily lose a digit. Then I'm down to 1 decimal. Ooh, depends. Just pay attention to what the question wants. 4, I'm still fairly safe, so I just got into the habit of doing that. So you didn't give me the other decimals. Now I need to do it myself. Oh, it wasn't even right. All right. Well, now I need confirmation from someone else. He says 2.2573. Good, good. So, zooming out. I can't zoom out fully. There's a lot of little things that we can do. And looking at the graph, I can't use the graph to confirm my X-intercepts, right? But I can sort of. Like looking at my graph, it would agree with everything else if I have an X-intercept that is a little negative and an X-intercept that is positive and a little bigger. I can't say like, oh yeah, of course that X-intercept is 2.25. No, but it does seem to agree. If I got 2 positive X-intercepts, that doesn't fit with the rest of the information. And I can use that as a little bit of a check to see, oh, maybe I did the calculation wrong. Something doesn't agree. And that idea of pieces of information having to agree with each other in some way, I can use, and that's going to come up in the later stage as well. All right. So I think we've seen pretty much everything there is to see, or review everything we need to review when it comes to quadratic functions. We have some transformations, and we're not done with transformations. we're going to now have the task of just expanding our basic functions a little bit. We have y equals x squared. That's not very exciting. What other basic functions can we add to that list to give us some variety? And for those other functions, still basic, what properties do they have? The transformations are the same, but it's nice to expand that library. Still, it should be fairly familiar. As we complete this week, that is still our review week to a large degree. And then slowly in these discussions, we'll cross over to concepts that lead us into calculus. So let's just maybe go and open the schedule and see where we're at. Just 1 second while I get it open here. That's not it. That's the problem book. Schedule. There we go. Okay. Let's have a look. We are here. So we are going to look at one kind of application of quadratic functions, just like we did for linear functions. We need to just keep some applications in mind, put things in context. And then the following day, you have a self-paced video where we talk about the other functions, mainly the square root function, that's sort of the big one, and then we move into polynomials and rational functions and so on. So be aware of the schedule, what's coming up, what time you're expected to do what, and we're slowly working our way through a review, sort of switching over to new things in next week. It'll come. Are there any questions at this stage? All right, then we discussion tomorrow.